Hi, my name's Finn O'Brien with Griven USA, and in this video I'd like to go over the DMX512 control protocol and some basic rules for implementing. Now you may be wondering what a protocol even is. Well, it's kind of like a language. It's just a way for two things to communicate. In the electronic world, it can be as simple as a light switch or as sophisticated as the Ethernet that delivers movies to your phone. DMX512 is a digital control protocol that was originally developed for the entertainment industry. It was designed as a versatile live show protocol that could change what a light fixture was doing up to 44 times a second, which is great in a live show environment. So you might be wondering, why is DMX used in architectural lighting? Well, it has some advantages over other protocols used in permanent installations. One, it allows for fast and frequent changes of the light fixtures, which is great for architectural entertainment. Two, it has 255 steps of dimming, which allows for precise levels set on the fixture, as well as smooth dimming between those levels. 3. DMX is an open source protocol, so it's not owned by a single company, and everyone should be following the same guidelines when implementing into their product. The 512 in DMX512 refers to the number of control channels available in a single universe of DMX. A simple DMX controller can output a single universe. Larger controllers can output numerous universes of DMX, but there are strategies for managing DMX distribution in those cases, and we'll tackle that in another video. Griven's RGBW fixtures can be set to use 4 control channels for individual control of red, green, blue, and white colors. If you take those 4 control channels per fixture and divide into 512 channels, you'll find that you get 128 RGBW fixtures that can be controlled in a single universe of DMX. But there are some important constraints to consider when trying to wire up that many units. For DMX compliant fixtures like Griven's, no more than 32 fixtures can be connected in a single run of DMX before the signal must be boosted or terminated. And those 32 fixtures must be connected within 1,000 cable feet from the source of the DMX signal. Now that assumes relatively even spacing of those fixtures along that length. They can't all be grouped at the end, because each DMX receiver consumes a small amount of power. An excessive cable length will introduce voltage drop, which turns into signal loss. If you're boosting the DMX signal in a run, or sending out multiple parallel runs to different locations, you're going to need to use an optically isolated distribution amplifier, also known as an optosplitter. Now the optical isolation is critical because it prevents any energy spikes from propagating through the system. And RDM stands for Remote Device Management, and we have another video that talks about that. But you'll want to use RDM-capable optosplitters throughout your installation to allow for bidirectional communication. Now remember, any splitting of the DMX signal must be done with an optosplitter. Griven provides IP67 splice kits for easy connection between fixtures. Use the butt splice connectors and match the wire color for easy connection, and use the heat shrink tubing to weatherproof. Now where you need to use DMX wire for extended gaps between fixtures, always make sure to use the bare wire or drain wire for DMX ground. You can consult the Griven pinout document to understand color coding for DMX Plus and DMX Minus. But if you have DMX wire that has different colors, the important thing to remember is to be consistent throughout the installation with which colors for DMX Plus and which colors for DMX Minus, because polarity matters. Another very important thing when splicing is never connect more than 2 wires into a splice, otherwise you can introduce significant issues into a project. And doing so would also be splitting the signal, and the signal can only be split with an optosplitter. If you're sourcing your own DMX cable, make sure to purchase appropriate outdoor rated DMX compliant or RS-485 compliant cable. Anything else can create issues with incorrect impedance or wire gauge mismatching that can introduce issues that can be time consuming to track down. DMX compliant fixtures like Griven's use a drop bus topology, which means for the data wires on the fixtures, it doesn't matter which one's used for data in and which one's used for data out. It also means that if a fixture fails, nothing else on the line is affected. Finally, when you get to the end of a run, the data cable must be terminated with a 120 ohm resistor between the DMX Plus and DMX Minus wires. This prevents reflected signal that can cause the fixtures to behave in erratic ways. And Griven can provide IP68 DMX termination kits upon request. Now let's do a quick review of the rules. No more than 32 fixtures per DMX run before the signal is boosted or terminated. No more than 1,000 cable feet from your DMX source to the last fixture in that run. Make sure the fixtures are spread out if the run is very long, or just use more runs. Use RDM-capable optosplitters for boosting or splitting the DMX signal. Use appropriate splice methods with no more than 2 wires in a splice. Be consistent with your wire color code throughout the project because polarity matters. And terminate at the end of a DMX run. Now that you have all the rules, you should be good to go. Thanks so much for watching. I hope you found this video helpful and informative. If you'd like to learn more about Griven or any of our products, please go to griven-usa.com or reach out to your local Griven agent.